Hi, this is Mr. Buford. Today we're going to work on the elimination method, which is a method of solving systems of equations in which you add or subtract the two equations to eliminate one variable. The steps to solve these questions are here. Step number one is probably one of the most important things you have to do. You have to make sure that the equations are lined up, meaning the equation parts, the x's, the y's, and the constants are lined up directly on top of each other. You stack the equations on top of each other. Also, make sure your equal signs are lined up too. And then you're going to decide whether you're going to add or subtract to eliminate one of the variables that have common coefficients. Down here, a common coefficient means they have the same number next to the same variable. And from that, you'll decide if the signs of the coefficients are the same, you will subtract the two equations. If the signs of the coefficients are opposite, you will add the two equations. Once you do that, that allows you to solve for a singular remaining variable, either x or y. You'll get the value of x or y, and you'll be able to substitute that value into one of the original equations and solve for the other variable, the one you eliminated in step 2. Let's go ahead and practice this. If you look here in equation 1, you'll see that I have step 1 taken care of. My y's are lined on top of each other, my x's are lined on top of each other, and my constants are lined on top of each other, as well as the equal signs. We're going to be looking for a common coefficient. If you look in front of the y's, both of these y's have an assumed value of 1. The coefficient in front of those are both 1. That makes them common coefficients. And since they're both positive, we are going to decide, so they're the same sign, we're going to decide to subtract these two coefficients. So step 1, we verified that everything is lined up. In step 2, we're going to subtract these two equations because of the fact they have positive same numbers. So let's go ahead and do that. You'll notice that y minus y, well, that'll give us a 0. And 3x minus x will give us 2x. 4 minus a negative 2 will give us positive 6. That allows us to solve for this variable x. And when I just use my basic solving skills, I'll take 6 from both sides, working on getting the variable alone. That will give me 2x equals negative 6. Divide both sides by 2. I find that x is equal to negative 3. In step 4, I'm going to take this value of x and I'm going to substitute it into either equation. I'm just going to go ahead and pick the top equation. So where there's an x, I'm going to put negative 3. So y, the value of y, is equal to 3. X is negative 3, so it's 3 times negative 3 plus 4. That allows me to find out what the value of y is by simplifying using order of operations. 3 times 3 is negative 9 plus 4. And add those two together, I get y is equal to negative 5. We report my answer not as x equals negative 3 and y equals negative 5. We report it as a coordinate pair of negative 3, negative 5. Let's try one more. Look at number 3. Number 3 are two equations. You'll see that the x's are lined up, the y's are lined up, and the constants are lined up, as well as the equal signs. You'll notice that the common coefficients in front of the x are 3. They're both positive, which is again going to allow me to subtract the two equations. Let's go ahead and do that. 3x minus 3x, well, that's a 0, x. Negative 10 minus a negative 9 gives me negative 1 y. 14 minus 15 gives me negative 1. So that gives me an equation, since 0x is 0, we don't need it. That gives me negative 1y is equal to negative 1. I need to get y positive and singular, so I've got division of negative 1 on both sides. I've got the value of y is equal to positive 1. I'm going to go ahead and substitute that back into either equation. Again, I'll take the top one. 3 times x, 3x, minus 10 times y is 1, is equal to 14. When I solve for x, I get 3x minus 10 is equal to 14. I'm going to add 10 to both sides to get the variable alone. That gives me 3x is equal to 24. Divide by 3 to remove the coefficient. I get x is equal to positive 8. Again, report your answer in a coordinate pair of x comma y format, so it's 8 comma 1. Let's look at two examples where we're going to add. Flip the paper over to the back and we'll look at number 5. Number 5, we'll see that our common coefficients are in front of the x. They're both 4, but they're opposite signs, which is going to allow me to add these two equations. When I add them, 4 plus a negative 4 gives me 0x. 9 plus 7 gives me 16y. 5 plus 11 gives me 16. Since 0x is 0, anything plus 0 doesn't change, so we can eliminate the 0 and say 16y is equal to 16. If I divide both sides by 16, I'll find that y is equal to 1. When I plug 1 back into either equation, again I'm going to take the top just for ease. 4x plus 9 times y, and y was 1, is equal to 5. I'm going to continue solving. 4x plus 9 is equal to 5. Subtract 9 from both sides. 4x is equal to negative 4. Divide both sides by 4. I'm going to get x is equal to negative 1. My coordinate pair is negative 1, comma 1. Looking at problem number 7, you'll see that my coefficients, common coefficients, are on the y variable this time, and they're both 1 and they're opposite signs. So when I add these two equations, I get x plus 3x is 4x. Negative y plus positive y, those cancel out, and I get 10 plus 18 is equal to 28. That allows me to solve for x by dividing both sides by 4, and I get x is equal to 7. I'm able to take that 7, plug it into either equation. I'm going to plug it into the bottom this time to show you can do it in either one. And I'm going to do 3 times 7, because there's an x there, put the 7 in its place, plus y is equal to 18. 21 is equal to, 21 plus y is equal to 18. I'm going to subtract 21 from both sides, like so, and I get y is equal to negative 3. And I get a coordinate pair of 7 comma negative 3. We're going to finish up the rest of these in class, so go ahead and make sure you have your notes ready to talk about in class. See you then.